Last time we finished working on our snake game clone, which was a 2D game using Raylib library. We learned quite a bit how to animate things. We added a few custom shaders for post-processing effects like glow, scan lines, chromatic aberration. And today we are shifting our focus from 2D to 3D, and we're gonna work on a new game named Tower Blocks. Let me show you how it looks like. So we will have a few blocks. The top one is always moving, and the idea is that you have to cover the underlying block as much as possible, and if you miss the part that is not covering the underlying block is being cut off. With each added block, the speed with which the block are moving is increased, so you won't be able to play it endlessly. So during this project we will learn how to set up 3D scene in Raylib, how to add our objects there. Eventually we will add our own lighting shader. We'll work on the same animation for text, like the score, the overlays for game over, game start, and so on. Hopefully you will find it to be very interesting. So I invite you to join me on this adventure, and I guess we can get started. First thing, as usual, let's create a new repository. Let's call it Tower Blocks. It's gonna be public. We can add readme, we can add gitignore as usual for C. We can create the repo. Once it's created, let's jump and clone it. Let's jump into the created directory. I am going to use template for Raylib as usual. Let's move it to C, make lists, txt. Let me show you what it is. Pretty much we're saying some minimum required version. We're going to name the project TB, which stands for Tower Blocks. I'm going to use standard 23 just because I like it. We are going to export compile commands, which is needed for my LSP. We are going to use some compile flags and pretty much compile everything in our SRC folder. We are requiring Raylib to be installed in our system, and that's pretty much it. So first of all, we need to create our SRC directory. I need to update gitignore with a few entries like cache and build. Maybe something else will be added in the future. Then, as usual, I'm going to create an alias, which is going to be cmake build and cmake build and build tv. So what it does, it creates the configuration cmake inside build folder. We run the build inside build and execute our main. Let's open it up. src create main c with usual dummy main void if sticky out. Okay, I'm here. Let's see how it works. And yeah, seems to be working fine. Our setup is done. Let's jump into our main. We can include probably Raylib right away. But first thing that we need to do is to look up some example which works with 3D scene. So yeah, this is like a very basic initial example. It tells you how to set it up to show you some cube. So let's start using that. Probably grab this first. So let's define our screen width and height. So window width and window height, which is going to be something like this. and let's rename it to tower blocks. Then we can close the window in the end. We need our while loop, while not window should close. We can begin drawing and drawing. So this is everything we need to just show the window, right? It's shown here. We are gonna clear background, let's say with white, to see that, yeah, we're painting everything correctly. We will introduce some background color, which is going to be, let's say, something like 210, 200, 190 with alpha 255. So our background looks something like this. All right, back to the example. We need what? So we need some camera, and we will need to draw some cubes, and it should happen in some begin 3D mode. So let's add our camera first, right? So we will have some camera 3D, camera 3D object. Oh, failed to jump. Let's grab all the parameters. So our camera position, right? It's a vector 3. We're gonna put it somewhere like, I don't know, like 10, 10, 10. So that's the position of the camera in our world. Target is where our camera is looking at. So we're gonna be looking at origin, at least initially, right? Up, we need to define an up vector, which in our case is quite easy. We're simply saying that y is up. We are not gonna edit the up vector in our game. Field of view, I think it was 45 in the example. Yep, 45. Let's remain it at that. And projection, camera perspective. So this is our camera. We can do begin mode 3D with our camera and mode 3. In here we're gonna like draw stuff in 3D, right? So this is pretty much what is required to start drawing things in our 3D world. Now the game is all about blocks, so we can start introducing some types for the game itself. Initial struct, which is going to be block. Let's say we're gonna have position. Let's say we're gonna have some size and probably some color. Right, so each block has position, size, color. We can also define some default block, right, which is going to be used as a template for all the other blocks. Position can be as easy as x, y, and z set to 0. So these have to be changed for every block that we're going to add to the scene. Size is going to be something like 10 by 10 by 2, so height is 2, and then there is like width and length, because y is responsible for height is 2 and set is 10. So our block is a square 10 by 10 with height of 2. And then some color, I don't know, we can initially define whatever we want, say 150, something like that. Doesn't really matter at the moment. So this is our default block. So at some point we will start drawing blocks. In order to draw the blocks, we need to start keeping track of them. That's where our game struct comes into play. And what we are gonna do today is simply add a structure with the parameter which says, hey, we're gonna have an array of placed blocks. So these are the blocks which have already been placed. They are not moving, they are simply there so that we can render them. Each of them will have its own size, own color, own position. So probably first thing that we need to do is have our game variable, then we will have some init game method, so void init game. For now it's enough to say that, hey, this is null. Then here it's going to be something like draw placed blocks, given what? Given our game placed blocks, something like that. So we will have another function, draw, this is block placed blocks, or just blocks probably. How do we draw them? We simply need to, alright, so before we can draw them, let's jump back to our browser, and again let's find the STB header only libraries. We have already used the dynamic array thingy. Let's use it again. I'm gonna create STB DSH, I think it was called, paste it in. So STB DSH, right? We are gonna create STB DSC file as well, where we're gonna include STB DSH, and we need to do some definition, yep, right here. So if you have watched my previous videos, you understand that this is needed for LSP not to go crazy, so that we define in a separate C file, and when we include STBDs in our main, then it won't go crazy on us. So now that we have those dynamic arrays, we can say that, hey, first of all, we need to know the blocks length, which is array length coming from STBDSA, with our blocks. Then for each block, we can say that, hey, please draw me a block. So this is as easy as saying like block. Sorry. What is a draw block? It's going to be something like this. So yeah, this example showed us DrawCube and DrawCube wires. Let's try drawing that. We can draw some cube. Block has position. This is block size X, block size Y, and block size Z, and block color. Now the example also tells us to show the wires. Let's see like what it does with the wires and without the wires. So if we tell wires and change the color to black, all right, if we run it, we can see our window because we don't have any placed blocks yet. What we can do though is add a dummy one. So let's say we can say, yeah, there is a default block. We can say, let's push this default block to our place blocks and see whether we can render something. And we do render it. You can see that it's a huge block. This is because we are, here is like our origin right here. Camera is at 10, 10, 10, which is not that far from the origin. The block is quite big. 10 by 10 by 2, so this height is 2. And this whole thing, the perspective, is that the further the point in the scene is, right, the smaller, like, oh, the object, the further the object is, the smaller it is displayed. So interestingly enough, this is one of those games where we can use an orthographic projection instead of perspective, right? So that whatever we see in the scene, it's not, it doesn't have any perspective. So it's shown as if it's there. Doesn't matter like what distance is. We can change the zoom level a bit, field of view. In this case, field of view is probably the thing that perspective projection use, but they decided to use the same naming, the same param for orthographic, but it is used to define the, how to say it, to block, not the block, but yeah, that frustum, even, yeah, I don't know like how to explain it easily. Let's find the old OpenGL, orthographic, maybe this one. Yeah, so orthographic projection, you have near plane, far plane, and pretty much the field of view currently defines the width, this param. And then Raylib calculates the height by itself based on aspect ratio of our window, and near plane and far plane are they default to something like something very near to 0, something like 0.001, and far plane, I don't know, 10, 20,000, doesn't really matter unless we hit some issues with that. Well, pretty much in case of orthographic projection, changing the field of view still acts a bit like zooming in, zooming out. So we can see our block. It has the wiring, which is black. Let me show you how it looks without the wires. It's yeah, kinda not looking that good. We understand that this is our block, but because there is no lighting, there are no shades, so it's hard to see the contour of our block. And that is one of the reasons we will have an episode dedicated to adding our custom shaders, which will introduce custom lighting to our scene. So we will work on one of the Learn OpenGL articles, which teaches us about basic lighting. So yeah, we'll do this ambient, diffuse, and specular, so that we have something like font lighting in our scene. For now though, we are simply going to use the DrawCube wires for the time being. Right, let's try to add a few more blocks to the scene to see how it's going to look like. So let's add like 5 more. Let's say block is going to be default block. We copy it over here. What we need to do is then push it, except that right now they all live in the same space, in the same position. They have the same color, which we would like to probably change. We can say that position Y is something like I+1 times 2, right? Because our height is 2, we would like to bump it up. Yep. So we have blocks on top of each other. We can also say that, hey, the color is going to be plus times 5 RGB. Yeah, so it's kind of getting lighter and lighter. Let's try to add like 50 blocks or something. And here we have our first issue. which is related to the near plane. So when we looked at learn OpenGL orthographic projection, it showed you that whatever there is in the scene, we are showing only things which reside in this box, and everything else is being cut off, not rendered. So in this case, our camera is too near to our tower, right? And it's simply cutting off the things that are kind of like behind our screen. So it decides not to render them. There is a very easy fix in our case. Because the orthographic projection is used, we can put camera wherever we want, pretty much just having it at the same angle as before, right? And we should see the tower correctly. There is no more cutoffs happening due to near plane. Yeah, we can even have it like at 500. Right, probably, yeah, it still works. That's how orthographic projection works. I will add the link in my companion blog to the article regarding orthographic projection so that you can read about it a bit more to understand how it works, how it differs from perspective projection. So what else do we need for our basic setup? Let's see. Let's work on our main loop. What we are going to do here. So each frame we are going to probably update game state. We are going to update camera position after the game state change, if it did change or not. And yeah, we're drawing things. So let's see, what is update game state? Right, update game state. For now, there really isn't much to do here, but yeah, we can probably handle some input right away. So let's introduce something like input pressed. So as I told in the beginning, we are gonna react to is key pressed key space, right? If I press the space button, or is mouse button pressed, which is mouse left button, right? So this flag indicates whether space button or mouse left button was pressed. And then if input pressed, we can probably just for now push this random block. Let's let's leave the default block for now. Let's remove these extra blocks and put them right here. Except we won't have any for loop, because for each press we're gonna add just one block there. This is gonna be default block. We don't have an I anymore, but we can say that I is going to be something like array length of our game place blocks. We don't need to add +1 anywhere. And that should be enough. Okay, we haven't added this update camera position. Void. Actually, we will need to have pointer to our camera here. We can say maybe unused for now. We need to pass camera here. Let's run it. So this is our base block, and now I'm pressing space. Yeah, as you can see, it's working. It's adding more and more blocks, except that camera keeps looking at 0, 0, which is like somewhere like here, like probably like middle of our screen. So what we would like to do right now is to adjust camera position based on the number of blocks so that it's always looking at the top block. How can we do that? It should be quite easy. We can say that, hey, like camera position Y is something and camera target Y is something. Okay, so what is going to be? It's going to be 2 times array length. So it's going to be, we'll need game reference. We will have to, well, we will have to tell it that placed blocks length is something like array length of game placed blocks. Then we can do it like that and target. Actually, no, this is not correct, because our initial position is at 50. So we need to say like 50 plus this. And here we can simply say that, hey, whatever the blocks you have, so this should be something like that, so that whenever we add a block, we actually push our camera position up, right? And the target, the look at point, is based on the placed blocks length. In case there are no blocks, we're looking at 0, 0, right? In case there is, the target is 2, and so on and so on. So right now I'm looking somewhere like here. So my mouse pointer, which I'm not going to move anymore, is pointing at the middle of the top block. And if I start pressing space, you can see that our tower starts to grow like in different direction to the bottom. Before it was growing upwards, now it grows downwards, although the top block is added here on top. This is where we go over the limit of our colors, which is only 1 byte. Yeah, so something like this. In our game, we will of course have to add some smooth camera movement. Right now, whenever the block is added, we adjust camera position to the new block right away, but we will have this movement a bit smoother, which will surely make the experience much better. So this looks like pretty much everything we need for our initial setup. Next time we're gonna start working on the blocks. Probably we'll make it move. We will differentiate between placed blocks and current block, which is like moving. We'll try to make them move. We'll try to understand how to cut off the block, and we'll work something out from there. I hope you like this episode. I hope you'll enjoy this series, and if you like this kind of content, please don't forget to subscribe to my channel. It helps me greatly. Thank you very much, and I'll see you again. Bye.